Good morning, friends. Now we are discussing CFD, that is computational fluid dynamics. So it is the science of predicting the fluid flow, heat and mass transfer, the chemical reactions involved in the fluid flow, heat and mass transfer, and the related phenomena by solving numerically the set of governing mathematical equations. So CFD is the simulation of the fluid engineering systems using modeling. So here modeling is the mathematical physical problem formulation. So the fluid engineering system will be modeled in the form of mathematical physical problem formulation and numerical methods like discretization methods, solvers, numerical parameters, and generation of grades. So the process of CFD is shown in the figure. So here the fluid problem. First physics of fluid, that is studying the properties, basic properties of the fluid will be involved. Then mathematics. So here the entire CFD is based on Navier-Stokes equations. Then so it will be put in discretized form. So these mathematical equations will be put in discretized form. So then grids will be generated. So then the generated grids using the suitable programming language. So the simulation will be done. So then the results of the simulation will be compared and analyzed. So the cycle continues. How does the CFD work? So any CFD analysis will basically consist of the following three phases. The first one is pre-processing. In this phase, the problem statement will be transferred into an idealized and discretized computer model. Suitable assumptions will be made concerning what type of flow to be modeled, whether the flow is viscous or the inviscid, compressible or incompressible, steady or non-steady flow. The other processes involved in this pre-processing stage are generation of mesh and application of the initial and boundary conditions. So that is very much important. So then the second stage is solving. So here the actual computations will be performed by the solver, and in this solving phase the computational power is required. There are multiple solvers available, so they are varying in their efficiency, capability in solving the physical phenomena. Then the last stage is post-processing. Here the obtained results in the earlier stage are visualized and analyzed in this post-processing phase. At this stage, the analyst can verify the results and conclusions will be drawn based on the obtained results. The ways of presenting the obtained results are, for example, static or moving pictures, graphs, or tables. So the applications of CFD. So here CFD is using in the fundamental research as well as the industrial research and development activities. So varying from aerospace, chemical, transportation to biomedical engineering. So here the applications of CFD are shortlisted. So it is used in weather forecasting, then the design of wings to complete the aircraft aerodynamic design. So that is in aerospace. Then in turbo machines, which CFD is used in the design of hydraulic, steam, gas, and wind turbines, design of pumps, compressors, etc. So then in engines, then in electronics, which includes the cooling of microcircuits, then the chemical process engineering. So then in various energy systems, which includes the analysis of thermal and nuclear power plants. Then in hydraulics and hydrology, which includes the flow in rivers, channels, aquifers. So then the design of ducts, placement of heating and cooling ducts for optimum comfort in a building. So that is air conditioning system and ventilation. So then the aerodynamic design of the vehicles, then in marines, the hydrodynamic design of ships, and then in biomedical, so that is the simulation of the blood flow through arteries and veins. So, and in the fundamental flow physics, so dynamics of laminar transition and turbulent flows. Then the various governing equations in CFD. So here we are having uh, the basic equations as three physics laws of conservation. So that is conservation of mass, so which includes continuity equation, then conservation of momentum. So that is the momentum equation of the Newton's second law, and then conservation of energy, so which includes the first law of thermodynamics or the energy equation. So these principle states that the mass, momentum and energy are the stable constants within the closed system. Basically what comes in must go out somewhere else. Thank you.